Hello, everybody, and welcome to the Testing Tips and Tools podcast, which is sponsored by Applitools, delivering visually perfect apps to your customers. For more information, please visit www.applitools.com. Welcoming our co-hosts today, I will be hosting as well. My name is Kaylin St. James. I'm a marketing associate of This Dot. My Twitter is at THEKAEWAY. My co-hosts are Amit Zur, which is the team leader in the engineering department for Applitools. His Twitter is at AMITZUR. Hey Amit, how are you doing?
I'm great. Very excited to be here.
Good. Next, we have Gil Tayar, which is a senior architect for Applitools as well. His Twitter name is at GILTAYAR. Hey, Gil, how are you doing today?
How's everybody? I'm great.
Wonderful. And finally, we have our guest, Guillermo Rauch, who is the founder of Zeit. Guillermo's Twitter is at RAUCHG. Hey, Guillermo, how are you doing today?
Great. Thanks for having me.
Absolutely. I'm so excited to have everybody on the podcast today. And Mitt, would you like to go ahead and start off with some questions?
Yeah, sure. Thanks, Kaylin. So first of all, I want to thank everyone listening and viewing us. This is the very first episode of Testing Tips and Tools, where we'll try to focus on testing. We'll try to focus on front-end testing. Basically, we'll try a lot of things, but the most important thing we'll try to focus on is just having good conversations and giving value to our viewers. So, without further ado, this time, like the very first guest that we have today is a super valuable person. We have Guillermo here. So Guillermo, you're gonna have to answer a bit of questions on our side. Are you ready for this?
I'm ready.
Great. So it's really exciting to speak with you today. It's so like the first thing I have to introduce is you are one of the most productive and fruitful developers or software people that I know of or heard of. Just a short list of very valuable projects that you're a part of or owned or wrote by yourself is Socket.io. You have the Now platform. You're the founder of Zeit. In your resume, I know about LearnBoost. Is that right?
Way back in the day with LearnBoost, we started contributing very early on to Express. We hired the creator of Express at the time. We created Mongoose, the MongoDB ORM/ODM that is pretty widely used today in the Node community as well.
So in your resume, there are a lot of projects that are both like library and frameworky projects, and also like full-fledged products, which will go all the way to the consumer. So. Yes. So the first thing I'd like to ask, like after all this list, what are you up to today? What are you doing these days?
As you pointed out, we've been working with a lot of really interesting Node.js tools for a while, JavaScript tools for a while. We've done a lot in the realm of deploying consumer products, scaling platforms. My previous company got acquired by WordPress.com, and we helped them scale their JavaScript infrastructure. So we've always been in this in between of creating great developer tools, but also serving end customers and end users. So nowadays, we decided to sort of take all these lessons of, okay, what are the things that make people productive when they're creating online experiences? And can we give that back to the community as a platform? So that's what we've done with Now and Next.js. So we decided to take all the expertise that we had on how to create this universal, fast websites and web applications and give them back to the community as a tool to deploy them instantly in a serverless manner.
That does sound so cool. So we were, I think, planning to discuss a little bit about Now further down the road. But now sounds like a good place to start by asking, can you tell us a little bit about now and the shift that it's done from version 1 to version 2, aka
Sure.
serverless?
Yeah, so now it started as a platform to deploy anything, any server, any website, whether it's static or dynamic. As of recently, we decided to double down on this idea of becoming a CDN for not just static content, but also dynamic serverless functions. So what you can do with now is you can deploy any sort of API, any backend, any CMS, any website, and you can do so without paying for when your website is not being accessed and scaling from 0 to infinity. So that's pretty much what the main idea behind serverless is. Everything happens sort of lazily. If you deploy a website or a web application, it scales commensurate to your traffic. You don't need to do any monitoring. You don't need to do any observability necessarily on top. You don't need to do any maintenance. And then you basically get charged for only what you use and only for what you're serving your customers.
Sounds awesome. So can you like share a few thoughts about like the reason to change, because now was already existing and looked very, very like a quality product. Can you tell us a little bit about like what were the main objectives or the reasons to like make the shift?
Yeah, so we host a huge number of applications and websites today. We've surpassed, the figures of millions and millions of deployments. And what we've observed when we looked at how our community was using it, how developers were using the platform, we realized that there is a set of constraints that are very useful to impose on a platform to enable the next level of scalability. Not necessarily, and going back to productivity, not necessarily computational scalability. I think in now V1, we're focused on deploying servers, and now V2, we're focused on deploying functions. And both scale really well with, in terms of, you can have a lot of traffic, you can have a lot of computation being done, and you'll be able to handle that traffic kind of equally well, I would say. But there's this idea of the team scalability that I call, or just like the human scalability aspect that I think serverless is where it really, really shines here. So when you deploy a server, you're sort of in charge of its monitoring and its scalability. If you've ever done anything with technologies like Kubernetes or just raw Docker, what it translates into is that you typically end up not only writing your code, but you have to write the probes and sort of continuous health checks to make sure that your code stays alive and well. So you have to do what's normally called a readiness probe and a liveliness probe. And furthermore, it's not enough to just ascertain, okay, the code works. And I think this is quite relevant to the subject of testing that we're going to be discussing today. So it's not only that you want to know that the code works, you also want to know that it works well, right? So typically what you do with services, you also have to set up not only your probes, but also memory and CPU and sort of number of active file descriptor handles, and you have to set up all this extra monitoring on top. So as we were scaling out our platform, we're kind of dealing with, having to constantly write additional tooling or additional documentation or sort of guiding our community towards this really good patterns. But when we sort of thought about it, it's like, okay, this is kind of contrarian to our original idea that deployment has to be seamless. So it's not quite seamless if you can deploy, but then in addition to all of that, you have to set up all this other infrastructure around, even if it's just more code or more tooling or more metrics and so on. So we decided, okay, what are the constraints that we can introduce into the system so that a lot of these things are no longer necessary? So when you look at serverless functions instead, and it's this lazy invocation-driven model where the computation only happens when it's invoked, you kind of naturally forgo a lot of these things. So for example, you no longer write a health check ever again because the act of invoking your code sort of becomes the health check. And monitoring becomes less of a burden. Sure, you're still going to be interested in knowing whether your code is executing fast, whether your database is responding in a timely manner, but a lot of the infrastructure for instrumentation, it kind of goes away as well. A typical example that I always reference people is that long-running code puts a lot of burden on the engineering team to sort of ascertain that it can run in a healthy manner for a very, very, very long period of time. And that's the part that we noticed wasn't scaling as well. Not from the perspective of, oh, the cloud cannot possibly run that code. It's more of, okay, what is the burden that we're giving the engineer? And what we've seen with Now 2.0 is that all of this additional burden of monitoring or deciding how your program scales just completely goes away. And it's even more true to the spirit of just deploy your code with one command, just deploy your code with one API call, and truly never worry about it again afterwards.
Cool. So is there a, yeah, Gil, go ahead.
Yeah, and not only that, the monitoring parts are usually the most difficult to test. They're basically impossible. So
Yeah,
you may think you're monitoring something, but given that you don't have tests, it's it's just a theory.
Yeah.
Yeah, sorry.
It results in the need for some sort of human intervention to know that the monitoring infra is actually running. And I think this is what serverless really shines in its model, right? The act of invoking and booting up a program in a cold way is also in itself the guarantee that the program is going to run correctly. So typically, the most basic test that you could do, which is like pingdom or anything like that, will already tell you that your application is running correctly or not. And even from an error boundary perspective, just knowing that you're responsible for one invocation at a time allows the developer to reason about errors in testing in a much more natural way as well.
It's true. So only one invocation at a time? That's interesting.
Yeah, so the main thing that is also a huge departure is when you think about Heroku, for example, the Dino model, you are thinking of a process that could be handling multiple requests concurrently. Now, the question becomes, how many can it handle concurrently? And that's why I was mentioning, sure, you can make deployment super easy with that model. But then what certainties or what contracts are you giving to the developer? And ultimately, you're not really giving them an operational certainty, because you're saying, okay, I booted up your process, your Dino, and we'll try to stick as many requests as we can into that one process. But you as the operator, you're not certain that when you get this 1,000th request that your process is going to work correctly. Whereas with the true serverless model of an invocation is a discrete process, and then the process can get reused, of course, but at any given time, you only are dealing with one invocation. You get the certainty that the scalability model and the primitives that are underneath are just much more understandable to you, the developer. And that's why I was referring to this idea is it's more scalable as far as what the developer understands about the scalability model, and just the certainty that, if you're go to bed and you have a huge traffic spike, you know exactly what will happen. For each new invocation of your code, a new discrete function instance will be created, and then when traffic goes down, they get destroyed. So it's a very natural way of scaling. It's a very natural way of reasoning about your code, about your APIs. It's just less stressful, I would say.
Yeah, and I love the insight that, just offload to the infrastructure whatever you can and be atomic in your like a processing unit.
Correct.
So I wanted to ask, like, when you write code for a product or a framework or whatever, like, how do you incorporate tests, or do you even? And also, I'd like to, another item in this question is, has your perspective on the subject changed in time, like as you progressed as a developer?
Absolutely. I think lately I've been of this idea of what I call incremental correctness. So, it's a funny term because we typically think of something as being correct or not, as a proof of being correct, or then you don't have a proof. But I think in the real world, we deal with a much more subtle notion of something works or something is correct. I would argue that what we consider to be working, or what we consider to be correct, or we consider to be safe, is more of a probabilistic measurement rather than an absolute certainty. So over time, my background was always in very dynamic languages that could deliver value very quickly. Funny enough, I've arrived with now 2.0 to what brought me to the beginning of my career, or sort of what got me started, which was PHP. So PHP deals with the same exact model as serverless functions or Lambda, which is for each discrete request, you get a quote unquote invocation of your PHP script. The PHP script only can deal with the life cycle of that request. And when it's done, all the memory allocation goes away. There's no risk for memory leaks. Requests cannot overlap with each other, so there is no risk of leaking data from a security perspective from one quote unquote PHP invocation to another. So I got started with this sort of really pragmatic approach to application development. And this is not a new story, right? So Facebook was created by hacking together some PHP scripts. Wikipedia was a sort of emergent experiment about how we can leverage hypermedia by linking everything, etc. So a lot of people got started with this idea of, hey, let's just deliver value to the end user or customer in the most direct way as possible. And every time I meet with my team, every time I meet with the people that are running Next.js today, I always remind them, hey, let's not forget that we're still not quite there yet in terms of that direct connection between request comes in, some lightweight processing happens, and HTML begins to be output at the other side of the stream. I think that's a very noble goal to strive for, because for someone that's getting started, for someone that's trying to scale or experiment or prototype their next big idea, I think that's where you want to start. So from there, from PHP, we moved into Node.js quite a bit. Node.js, I think, was very interesting in that JavaScript is the ultimate prototyping language. But it's not so good in its deployment mode, because PHP had this sort of no-brainer deployment mode, which is, hey, put it inside the LAMP stack, use a very high-performance, battle-tested web server in front, namely Nginx or Apache, deferred the scalability hard work to those, and you only write the code for the life cycle. So as we moved towards Node.js, we kind of gave that up. So we moved into this stateful model of computation where you're responsible for booting up the server from scratch. We go back to all the aforementioned sort of complications in the deployment model that I mentioned, like every time you create Express server, you're going to have to define a readiness probe and a liveliness probe, and you're going to have to monitor it, and you're going to have to make sure that you don't exhaust the event loop of Node.js, and then you're going to have to reason about how many processes you're running in terms of clustering and so on. But what we did gain is that I think, as I mentioned, JavaScript is an extraordinarily good prototyping language, aided by this gigantic library, NPM, of, I would argue, and perhaps it's a little harsh, of the prototypes of other people. And I think this is sort of what we as a community have come to understand at this point, is that NPM and JavaScript are a huge repository of experiments and prototypes. And you'll find this the hard way, perhaps. Like you'll use a module that seems to do everything it's advertised to do, and then in production you realize, oh, it didn't quite do what it was advertised, or the author decided to pull the plug and it's gone. But I would argue, in the spirit of finding what's correct as the light at the end of the tunnel, that this is a good thing. I think JavaScript will put you into this mode where you learn it by opening your IDE that is inside your web browser already. So there's this direct connection between the consumer that can also be a creator, and it's starting to like copy and paste a little bit of JavaScript and trying it out. You see this on online communities where people are always modifying, sometimes to create jokes, or modifying websites. You get it started so easily. You start prototyping anything, even from existing creations, but that is not going to lead you to a robust, correct, stable path. It's going to get you started, but then this is where the idea of incremental correctness in my mind kicks in. And I've been an advocate for Flow. Most recently, we've been using TypeScript a lot more. But I'm a fan of this idea that you can start to add constraints to your code while retaining that initial prototyping velocity. So one successful strategy is, oh, I now understand exactly what am I supposed to do with my business. Or I already know exactly what I'm supposed to do with this API. So that's where actually you can start leveraging a lot of this interesting new technologies, right? So if you're thinking about, hey, I'm gonna create an API that's gonna receive a lot of traffic, I'm gonna go with serverless. If I cannot tolerate any sort of security problem, serverless helps me as well with the discrete invocation model. Oh, and if I have to strive for very correct operation without me having to do all the heavy lifting, I'll use serverless. Oh, and also if I have to make sure that my own understanding of the code is correctly communicated inside of it, and that I didn't retain information about the types in my head, and I can correctly communicate this to the community or my coworkers, I'll use TypeScript. So that's where this idea of incremental comes in. And I think tests are, for me, in this journey of understanding or progression, I've come to sort of divide my strategy in terms of, okay, first of all, there's some problems that you can solve with type systems, with the understanding as well that type systems are becoming more and more powerful over time, which is something that is interesting from a research perspective. And also then there is the testing, which my preference is, let's test with as close to the boundary of the end user experience as possible, so that I can test my system with the interactions to other systems. Because I think that's what gets lost in a lot of times with the testing discussion. Your system doesn't live in an isolated world. Your system gets deployed to a cloud. It interacts with the load balancer, it interacts with DNS, it interacts with the cloud, it interacts with the web browser. So my main hypothesis with regards to testing is, testing is a very effortful process. It requires an investment. What are the things that we can do to reduce the investment and get the most out of testing as possible? So for me, that's been, let's write tests that simulate the end user experience as much as possible. And then let's prioritize what tests we write so that the ones that can capture the most value for our end customers as possible to begin with. And then let's also incrementally deliver more and more certainty through tests.
That's an interesting thought. So most of your tests are test the whole application in one thing.
What we try to do, it's hard to say. So we operate a lot of very complex systems. So we have tests of every kind of variety that you could imagine. So the typical distinction that people make between unit, integration, functional, end-to-end. At this point, we've covered the whole spectrum. But in terms of what's my philosophy, I would say when your idea of the code, your understanding of the model that you're creating for it needs to be ascertained, ideally, through the code itself. Just like mathematics will render a invalid proof invalid from the get-go, and you don't need to add any other apparatus other than your own progression and understanding of each sentence or a statement to the next. I think we need to do as much as possible from the code itself. So I think that's where JavaScript has traditionally been very criticized, because it's almost putting you in a position to fail from that perspective. The operators are give you uncertainty. It's full of uncertainty. And I was mentioning earlier that I think the idea behind tests is that they'll give you certainty. So, but when we start introducing constraints, like we do with TypeScript, like we do with TypeScript with strict mode, you start getting the idea of if it compiles, it's correct. But I think where a lot of people get hung up on is that because it compiled and it's correct, doesn't mean that it's going to work well for the end user, because what I care about is that it's correct in its interaction with all the other systems that I'm not controlling, or that I'm not necessarily, as I'm developing, interacting with. That's why we're hearing so much about this sort of trope or meme of testing prod or testing production, which is the idea that we enable with now, that we say, hey, the cost of deployment has gone down so low, and the easiness of deploying is literally writing 3 letters and pressing enter, that we want you to test in production as much as possible. And we don't mean testing production by, hey, replace your production website quickly with what you're developing. But what we're saying is deploy it to the same environment, make it connect to the same database, even if it's a staging database, but make it connect to the same database region and gateway and system, so that you're validating your hypothesis in relationship to all those very complex systems that can also fail. And I think that's what a very broad integration or end-to-end test captures. And that's why my tweet of write tests, not too many, mostly integration sort of captures. And what I mean by mostly integration is sort of as an investment strategy, because as I said, as a business owner, you always have to say, okay, like, how much of our time do we devote towards pursuing 100% test coverage? How much of our time do we devote towards blocking every release on millions of tests running? So it's always a tension between business requirements, proficiency of the team, of correctness tools that the team uses, experience with the interactive systems that I mentioned. You know, the more you work on the same system, the better you become at it. But also this idea of what are the tests that you wrote that are giving you the most bang for your buck? And by buck, I mean time writing tests, but also time executing tests, and so on.
Yep. You know, I always tend to ask people ask me how many tests do you need to write. I tell them as little as possible, and I love your quote. I mean, it should be everywhere. But it's not only that. What I tell them is, don't worry, you won't get it right the first time. You will have bugs in production. Bugs in production are fine. What will happen is those bugs in production will show you where those other tests that you need to write will find, and your tests will improve, just like good wine. Except that, except that they never, except that they never.
We need to compare coding more to wine. Just kidding, but we need to compare it more to things like that, because there is this idea that you just become better at doing the same thing over and over again. You develop a taste for it. You're like, oh, like this test seems right. Like this, it captures the spirit of what I want to do correctly. That's why it's a matter of quality more than quantity. Like I've seen tests that don't test anything, like the typical, right? And we'll never probably have mechanisms to ascertain that a test is good. That's why it is a matter of taste. We'll never have a system. It's kind of like the halting problem. It's an decidability problem that I say, oh, this test is a high quality test. It captures the spirit of what our consumers and customers need. But also the part of the quote that refers to most, not too many, is trying to emphasize that you should not strive to write tests as a replacement for thinking about the correct way to model your problem / write use the right type system / use the right abstractions. And a data point for this is that people tend to criticize C as being a language with a lot of problems, a lot of safety problems. Microsoft came out with a figure the other day that 70% of security or safety bugs are memory overrun bugs, and we've heard this for many years now. But something that I always think about is the GNU tool set of programs for me has been literally bug-free for decades. Like some of these programs that we use every single day would have not even been touched. Like you go to the release notes and you go to SED, for example, SED. They're like last release 1995. Imagine if that was a GitHub repo where people tend to have the knee-jerk reaction that if a commit is older than 2 days, the project is abandoned, right? So there's this idea, I think, that if you're able to correctly model your problem. So I go back to Unix because they did it so well with small programs that do one thing and one correctly, and with the Unix process model, that a lot of the things that have to do with correctness bugs, you don't even see that these programs have a lot of tests even, but they just work perfectly. And I think it has to do with they reduce the surface. Obviously, they had an expert level programmer in a lot of cases, so you have to account for experience always, as I said. And I think modeling the problem correctly leads to fewer bugs regardless of tests. So I think the mostly integration and not too many has to do a lot with, in a lot of cases, adding a lot of tests will give you diminishing results, but also not even help you that much because your model is incorrect, because your understanding of the problem is incorrect.
So in that aspect, Guillermo, do you feel how do you feel about the challenge, like in front end testing, because it's quite different between the two worlds of front end testing and back end testing, and front developers are facing sort of a challenge. So what do you think about the world there?
Yeah, so I think the problem has a lot to do with states. So I'm glad we started the conversation with discussing process versus serverless functions, because it's very similar. So one of the things that serverless functions will give you is a result, no pun intended. If a request comes in, they'll give you a result. They won't just run forever and accumulate states. So for everything that you do, there is a concrete response, a concrete answer. So that makes testing extremely easy. You either test the entire snapshot of the results. You say, hey, get website.com/API/users.php. Get me the result and I'll test it. With front end, in a lot of cases, there is no end. So we've invented ends. We said, okay, let's test what the state is at DOM ready, or let's test what the state is at onload, or let's try to wait. A lot of tests for simulating sort of browsers and whatnot are written by making the developer wait for some constraint to happen, like wait until this selector matches. And those are useful tools to try to recover what I think fundamentally is the model that makes testing very, very trivial, which is a function. So input comes in, output goes out, ascertain some assumptions about the output. So I think that's number one problem that front-end people have, is that there is no scheduling model that is conducive to making this sort of super easy testing happen. In fact, you'll notice that a lot of front applications struggle with even presenting errors to the user because there's no end. They can't just like say, oh, we're trying to show you this, and now we're going to show you an error page. You'll find a lot of half-broken states, because now there's sort of this combinatoric explosion of error handling that has to happen in a lot of component leaps.
Some things went right, something went wrong. So exactly. How do That's right. So, and exactly. I also think what you're saying is true also in the aspect of what exactly is the state. Is it some state in the memory of the process of the browser, or
Correct.
is it the DOM, or is it the DOM, or is it the visuals? So,
or a screenshot testing, is it what the user is seeing? Is it the pixels on the screen, right? Because that's why I've always sort of not been a fan of the idea of a state management library, because of absolutely what you're asking is such a obvious but not obvious to many question. What is the state? When you say state management, are you managing all the state? Are you not even using closures which capture scoped state inside the program? What do you put inside Redux? Like, that's always been a question to me. Like, what state? All state? Then the program is nothing. It's just a stack. So because of that, I think front has made it very hard to test, because no one has a good answer for this. So, and I think the appeal of Redux was a lot for trying to have some normalcy to this. It's like, okay, at long last, I can finally make some assertions about a common sense normal data structure, which is my Redux sort of reduced state. But that's why I think a lot of people are going with screenshot testing as well. It's like the system is so complex that let's look at the frame buffer state. Let's look at the state that went to the GPU or screen, and let's compare the pixels on the screen as a resulting state. I happen to think that if we continue to develop systems that have inherent complexity, that have all these interactions between, fetching data dynamically and lazy loading and intersection observing when you're scrolling and this and that, I think that kind of approach might be a good one, because as I said, my main central thesis is let's test what the user is experiencing, or as close to that as possible. So a series of snapshot assertions based on what they're seeing, and snapshot assertions based on getting the information that they need, for which you can make DOM assertions usually, tends to work well.
Cool. Yeah, I'm very fond of DOM assertions, and combined with actually visual testing as a strategy. I'm not using this as a shameless plug at all.
Yeah.
But now I have to say that as a front-end developer, I find the quickest tests to run to just assert that the object structure of the state is right. Then the second one is like JS DOM, just to see that the DOM is pretty much what I'm expecting to be. But I relate very much to what you're saying, is the test should really resemble how users interact with your application. So yeah. I always feel that if I stop there, the tests don't really represent exactly.
One of the things that we're working on is this idea of test in prod, right? So you can do that today with Now, because every push to GitHub gets deployed, and it's its own discrete deployment, own discrete URL. You can deploy locally from the command line by running Now. But what's interesting as well is how can we get meaningful data about whether my deployment works? So that's where I think we can make a lot of contributions as an industry, because typically the data is limited to what you can do as a developer. You go in and you test it. What you can do as a developer in terms of writing tests, which is useful, but like it still requires quite a bit of manual work. And the inputs are limited. It's whatever you decided to sort of put in the test that become the inputs that your program is getting like probed against. But there are two main things that are not being done that need to be done. So one of them is almost every company has accrued historical data about inputs. So with Now and the invocation-driven model, we're basically capturing everything that goes to invoke a function, right? So when we get your deployment, we can run it against historical data. We can replay old requests to see if your code is working correctly. From the perspective of front-end interaction, you could, replay it against older sessions of user interaction, especially against the areas of the application that have not changed. So imagine that you worked on a new section for which there is no meaningful data yet, but all the other sections of the applications that you've worked on could be played against historical sessions as well. And the other interesting point is, once you have some level of confidence that this could meaningfully be put in front of end customers, the idea would be that we do a progressive rollout, such as giving it to 1% of traffic, and then rolling back if we consider that metrics have changed. And what I mean by metrics is, for example, error rate increases. So this is the most obvious one, which is all of a sudden the developer rolled out a typo and is crashing for 1% of users. So let's roll it back automatically. You could argue that's superior to the developer striving for perfect correctness in a silo of their computer, the inputs that they can imagine in their head, and so on. But furthermore, I think error is too opinionated of a term for, or it's a special case for something I don't want. So someone that's running a business will understand that the only thing that you're trying to minimize is not errors. You're trying to maximize conversion. You're trying to minimize churn. This goes into the performance testing area, right? Like if Amazon.com becomes slower by 100 milliseconds, they lose a lot of money. So errors for them is not sufficiently good of a signal to decide that something cannot be rolled back, right? So that's what I'm saying. In general, we need to take this approach that we need to have a bar for correctness that gets decided by our own models, our own checks, our own proofs, our own type systems, combined with tests that we've also, some of them could be written tastefully and manually. Some of them could be supported by existing data and historical data. And then there's the idea that whether something is correct or not, it's not just because it didn't exit one in terms of the Unix model or because it threw an exception, but it's also because it didn't perform to your expectations. So that's where, it's not only just about an error metric increase, it's also about, oh, we're no longer creating signups for my company. That's just as bad as, it doesn't matter if, all your screenshot tests passed, all your, correctness tests passed. If that metric goes down, then the program is not fulfilling what it's designed for. And in this case, now we'll roll your code back. But I think that's why I wanted, sort of as a takeaway, we need to have a very broad idea of what we're striving for in terms of correctness, in terms of it works. It works is very, very broad and has to do more with a successful operation of a business or a product or an open source project than only, oh, I just received an uncaught exception.
Fantastic.
That's
Kaylin?
awesome. Yes, thank you so much, Guillermo, for joining us and sharing your expertise on testing. I certainly learned a lot today. And can you please just let everybody know one more time how to find you on social media?
Yeah, mostly I'm on Twitter, Rauch, G, R-A-U-C-H, G. I also encourage everyone to go to now.sh, which will take you to our website. Just enter https now.sh. And as far as our testing endeavors, we invite the community to develop integrations on top of our deployment system. This week, we rolled an improvement to our Github integration that'll mark every, what was before just a GitHub check, meaning that it was giving us a check mark and then you would press the check mark, press details, and it would go to your deployment. We're also marking each push as a deployment. So everyone that's writing testing tools or wants to experiment with testing tools can now capture the deployment automatically and run tests against that deployment through GitHub, which means if you submit a PR, now we'll deploy, and then any other testing tool can be set up on top to capture the deployment URL, run tests, and then you can confidently merge your PR. And finally, a lot of people in our community have been using our serverless functions to run headless web browsers. So on our blog, we recently wrote about how you use Puppeteer in combination with serverless functions. And this is something that I think is super underexplored and it's super exciting. So we're using it today to automatically generate images, automatically generate screenshots. Today, someone created an API for extracting CSS dynamically, because each function boots up a web browser, visits a website, and then extracts all the CSS dynamically. And then he exposes an API for that. So I think this is the next frontier for testing, because what before you would run in a VM with Travis or Circle, you can now run as one discrete serverless invocation per test, which means you could run thousands of tests in parallel, each of them booting up a headless web browser. And you're in complete control of the entire sort of logic for what those functions run. So I think that's going to be the next wave of innovation as far as testing. It's basically, just to introduce a buzzword that I leave you all with, it's serverless testing.
Wow, that is awesome. Thank you so much, Guillermo, for the information. Right?
All right.
And thank you
thank you.
Oh, no problem. Thank you for joining us once again. And thank you to our co-hosts. Amit, can you tell them how to find you on social media one more time?
Sure, the best way would be on Twitter. That's at Amitzur, AMITZUR. I think that'll be the best way.
Perfect. And for you, Gil, thank you.
Hey, I'm on Twitter mostly. It's GILTAYAR, and if you're interested in testing, anything about testing, I tweet about that a lot. I also talk specifically about visual testing. So you talked about screenshots there. So while we do have the SDKs to generate screenshots, I think the biggest forte of Applet Tools is generating differences between those screenshots.
Nice.
So that you'll know that in regression-wise, your application still functions. And we do that in an algorithmic manner so that you won't get all those false positives and false negatives that I'm sure you all are getting a lot when doing these kinds of things.
Thank you, Gil. And that actually ties in for if you are wanting to hire Applet Tools to help make that app perfect. Please go ahead and visit them at www.appitools.com. Once again, I am Kaylin of This Dot, and my Twitter is @THEKAEWAY. Had such a fun time with you all. Once again, thank you so very much.
Thank you.
Bye, everybody.
Thank you very much.